So this is our Calculus Quiz 4 practice video. Number 1 says, given the graph of f of x, identify the x values where x is not differentiable and explain. So anytime we have a hole, so like we have one right here, right? Y'all see that? So that's going to be x is equal to -2, and that's because it's removable. Remember, that's what that means. Okay, and we're just going to go from left to right. Now, also notice right here, I have a real sharp turn. We call that a cusp, right? So that's where x is equal to 0. So that's going to be a cusp. And then I see another hole right here where x equals 1. So that's another removable. Because remember, the graph has to be smooth and continuous, okay? That's the key to this, okay? Notice here again we have another sharp turn right there at 3, so x is equal to 3. That's going to be another cusp. And then we have one more right here at x equals 4, which is another removable because it's a hole. Alright, so let's go on to the next one. So this one says for number 2 through 9, calculate the derivative using properties. Okay, so recall here again, we are going to move this to the front, so we're going to do 3 times 8, and then we're going to subtract 1 from that. So that's going to be x to the second minus, and again, if we were to do this, this would be a 1 up here. We would be multiplying it by that. So minus 12 times 1, 1 times 12. And again, 1 minus 1 is 0, right? Sorry. So that would be x to the 0 power, so that would just be another 1, and a constant goes to 0. So 3 times 8 is 24, x squared minus 12. Okay, this next one, I'm going to put it in another form. So I'm going to say 10 times, this is going to be 1 over the square root of x, right? So what is that? That's going to be, remember, this right here is x to the 1/2 power, but it's in the denominator, so it's negative, right? So this is going to be 10 times our x to the -1/2. We're going to write it that way first, then we're going to do it. So we're going to multiply this up here again. So that's going to be -1/2 times our 10. And then we're going to subtract 1 from this, which remember, 1 is the same as 2 over 2, and I always give them a common denominator. So now we got a -1/2, and we're combining it with a -2 over 2, so that's going to be negative. So when we do this, sorry, this is going to be times x to the -3 over 2. Now what's -1/2 times 10? That's -5. And now this is, again, going to go where? It's going to go to the denominator, right? And this is, remember, I said ID. Index, that's the index right there, is always our denominator. So that's going to be our 2 right there. So this is going to be a square root of x to the 3rd. So that is our final answer right there. -5 over x to the square root of x to the 3rd. Okay. So here again, multiplying this up here, subtracting 1. So that's going to be 2 times 5 x to the 1st, right? Okay. Here again, we're going to multiply this over here and subtract 1 from it. So that's going to be -3 times -2 x to the -3, right? Okay. So this is going to simplify to be 10x. And then this is going to end up being plus 6 x to the -3. Remember, we don't leave a negative exponent on the top. So this is going to be 10x plus 6 over x to the 3rd. Okay, our last one over here is, again, I'm going to write this as a fraction. So this is going to be x to the 4/9, right? So once again, once I do that, I'm going to multiply this up front, and then I'm going to subtract 9 over 9 from this. So that's going to give me 4/9 x to the -5/9, right? Okay, remember, if it's negative, where does it go? To the denominator. Okay, so this is going to be 4 over 9x. Okay, remember, index is the denominator, right? So this is going to be the 9th power. I'm going to go ahead and do this in a different color so you guys can see it more clearly. The 9th power of x to the 5th. And remember, it's in the denominator because it's negative, okay? All right, so let me see if I can get a little more room here to work. Okay, so here we go again. So we are going to multiply this up front. So that's going to be 4 times 6. Subtract 1 from that, so that's going to be x to the 3rd. This x goes away, so this is just going to be plus 7, plus 12, and again, I'm going to make this x to the what? 1/3. Remember, index is the denominator, plus, and we're going to do this one for x to the negative 3. Okay, now we're going to keep simplifying. Okay, so this right here is just 24x to the third. We already did subtract up there, so this time we're going to subtract 3 over 3 from this. We're multiplying that up there, so we got our plus 7, right? So 1/3 of 12 is, what's 12 divided by 3? That's 4, right? Okay, so that's going to be then x to the negative 2/3. Again, because why? Because when we subtract a bigger negative from a smaller number, then we get a negative number. Plus, again, this time we're going to multiply this up here. So that's going to be 4 times negative 3, and we're subtracting that 1 from there, so that's going to be x to the negative 4. So let's keep going. So this is going to be, this is already simplified, 12x to the third plus 7. This is going to be plus r4, and this is going to be the cube root of x squared minus 4 times negative 3 is going to be 12, and then this x to the fourth is going to the denominator, right? So I'm just double checking and making sure I didn't make any errors. Yep, we are good. Okay. Number 7, again, bringing that up to the front, subtracting 1 from there, so that's going to be 33x squared, right? This is going to be, and I'm going to write this way, 1/6 times x squared. And then we'll take it down. This is going to go away, and that's going to go away. So this is going to be plus 2, right? Constants, remember, go away. Okay, so on this one, we're going to multiply this out front again. Okay, so when we multiply that out front, this is going to be, actually, let me do that in a different color so you guys can see it. Okay, so that's going to be 33x squared. This is going to be negative 2/6, right? And then subtract the 1 from there, so that's just going to be x, right? And then we're just bringing down our plus 2. So this is going to be 33x squared. And this can be reduced to minus x. It would be 1, right? Okay, maybe I should do that first so you guys can see it. Minus 1/3 x, which would make the x on the top, right? So if we were to simplify it, it would be 33x squared minus x over 3 plus 2. To our next one. Here we go again. So this is for bringing that up front. Subtracting 1 from that. So that's going to be 2 times 6, which is 12x to the 5th. Bringing this up front, subtracting 1 from that. So that's going to be plus 20x to the 4th. That x goes away, so that's minus 14. We're going to look at this one. I'm going to write it in a different color because I'm going to still have to reduce it. So it's going to be 8. I said I was going to write it in a different color, and then I didn't. 8x to the negative 4, right? So we're going to subtract 1 from that, multiply that up there. So this is simplified as it can be, 12x to the 5th plus 20x to the 4th minus 14, and then this is going to be negative 4 times 8, so that's going to be negative 32. X to the negative 5, so we're going to take this one more step down, 12x to the 5th plus 20x to the 4th minus 14 minus 32 over our x to the 5th. And again, that's because it's negative, so it's got to go to the denominator. All right, let's work on number 9. Okay, so this is going to be 10 times negative 5, so that's going to be negative 50x minus 1, so that's 10 to x to the 9th, right? Okay. And then we're multiplying this again, so this is going to be plus 42x, subtracting that 1, so that's going to be x to the 6th. All right, this one we're going to write, again, I'm going to do it in a different color because I'm going to still have to reduce it. So this is going to be 15, and this is going to be x to the 3/5, right? And that's going to go away. Okay, so on this one, what are we about to do? We're about to multiply this up here and then subtract 5 over 5 from it, right? So we're going to just bring this down, minus 50x to the 9th plus 42x to the 6th. And 3/5, 15 divided by 5 is 3. 3 times 3 is 9, right? So that's going to be minus 9. And then this is going to be x to the negative 2/5, right? Okay, so where's that going? So once again, it's going to go to the denominator, right? So let me go red here. So this is negative 50, x to the 9th plus 42, x to the 6th minus 9. And this time, again, we're taking the 5th root of x squared, and it goes to the bottom. All right, so our next one says identify the types of discontinuity and the x values. So for number 10, and actually 10 through 12. So here we've got a graph, right? So notice here we have a jump at, what is this value right here? X equals negative 2, so that's jump discontinuity, right? Then we have another one right here, right? And this is removable, right? So this is going to be x equals 1, and this one's removable. Okay, so if you remember on the next one, we have to factor the numerator, right? So the numerator is going to be x plus 9, x minus 9. Hopefully you guys remember this. And then we got that x plus 9 here. So these two are going to cancel each other out, right? So that means we have a hole there, right? So what do we call that when we're talking about discontinuity? So we're going to set this x plus 9 equal to 0. So x equals negative 9, and that's going to be removable, right? Because it's a hole. All right, let's factor this next one. So here again, I'm looking at what are the factors of 36 that add up to be 15. And so I got x plus 12 and x plus 3. Then what are the factors of 21 here? Negative 21, sorry, that add up to be negative 4. And that's going to be x plus 7 and x plus 3 again. So again, notice here that these guys are going to cancel each other out. Trying to change my color here. So that's going to be x plus 3 equals 0. So x equals negative 3. That's going to be another removable, right? Okay, and then if we have something left in the denominator like we do here, right, that's going to be a vertical asymptote. So this is x plus 7 equals 0. So this is going to be x equals negative. Well, wait. That was supposed to be negative. Sorry, y'all. So that, let me fix that. Yeah, that was supposed to be negative minus 7. So x equals 7, right? And that was negative because that's negative. All right, so that's at x equals 7. And remember, this is a vertical asymptote because it is a factor that's left in the denominator. Thus, this is infinite. It'd be great if I could write, huh? Wow, let me try this again. There we go. That's infinite at that point, okay? All right, so the next one says evaluate. Now, when it says evaluate, what does that mean we're doing? We are going to simplify it, and then we're going to put that negative 8 back into the equation, okay? So on top, again, I have, what are the factors of negative 48 here that add up to be 2? And so I got x plus 8 and x minus 6. And we've got our x plus 8 down here. And these x plus 8s cancel each other out, right? These guys cancel each other out. So we're left with x minus 6, right? So what we're going to do now is plug that in. So we're going to say negative 8 minus negative 6 equals negative 14. And that's our answer. Okay, on this next one, let me see if I can move this over some so you guys can see the whole thing. There we go. All right, so notice here it says evaluate the limit of f of x when x approaches 2 from the negative direction. Okay, so if we're approaching 2 from the negative direction, that means we're looking at all the values here that where x is less than 2, right? So this, again, think about it like this way. If we've got 2 right here and we're coming from the negative direction, we're coming from that direction, right? So that means all our values would have been less than 2. So we're going to actually look at this equation right here. That's the one we're going to use, and we're going to plug the 2 into that. So we're going to say negative 1/2 times our negative 2 minus 1. We're looking for what value that is, right? So negative 1/2 of, whoops, not negative 2, my bad, y'all. So that should have been a positive 2 because this is a positive 2, not a negative 2. So that's, let me try that again. Okay, so this is times 2. because we're plugging in 2, but coming from the negative direction. So that's negative 1, right? Minus 1. So our answer is going to be negative 2 here. Okay. All right, so our next one, number 15, says evaluate or use the graph to identify the limit values. Okay, so as x approaches 3, so notice that this value right here, it says is 3, negative 1, right? So as x approaches 3 there, what is the graph approaching? It's approaching negative 1. It even tells us that in that, right? So we're approaching where right here? That negative 1. See that y value right there? Okay, then as x approaches infinity, so now we're talking about out here. As we're going that direction, where is the graph headed? Notice it's headed towards this horizontal asymptote, right? So that means that our graph is approaching negative 3. Remember, we're always talking about y values here, so we're looking for the answers. So on the next one, as x approaches 0, so 0 is right here, from the positive direction, we're talking about that right there, right? So that again is 0, 1, so that's why the answer is 1. And then we have as x approaches 2, okay? So now notice here, this is 2 right here, okay? So as we're approaching from both directions, right, our 2, what's happening to our graph up here? It's headed towards infinity, isn't it? Okay, so that's the answer. All right, so for number 16, it says use the graph to identify the limit values. So here again, so this time it says the limit as x approaches 0 right here. So we're talking about 0. That's our value. What is the limit? What is it approaching from both sides here? That's our 1. Okay. Then the next one, it says the limit as x is approaching 3 from the negative side. So let me change my color here. If we're going towards 3 from the negative side, then that's going to be a negative 2, right? See our negative 2 value right here? Okay. Then it says, what is the limit of g of x as x approaches 1? So as x approaches 1 right here, so that's right there. So from both sides again, what are we approaching? We're approaching 0 there, okay? And then as the graph approaches infinity over here, the graph here is headed towards negative infinity, isn't it? Okay, those are your answers.